Okay, so we just talked a little bit, very brief introduction to simple harmonic models, and that's actually adequate for this basic trig level course, what we talked about right there with either a cosine model or a sine model. What we want to do is spend a few minutes now talking about what happens when you start adding functions together. Now, let's start with something simple. Let's say I take an algebraic function like just a linear function x, and I add to it a sinusoid. Let's add sine x to that. Now, the way that I would suggest that you first handle this sort of thing is, I mean, you can always grab your fancy calculator and look at the pretty picture, but you don't learn a whole lot from that. So what I would suggest you do instead is that you actually think of the graphs of both functions and imagine then adding their y values together. And that should make sense to you, adding their y values together. So if you graph the function y equals x that you're real familiar with, and we'll draw that. Actually, I'll go ahead and draw it right now, and let me dot it. And I'll call that y1 equals just x. And then I want to draw and lay on top of this one a graph of sine x. Now I want to be careful with my scaling so that I match the scaling. So if this is roughly drawn at 45 degrees, then, and if I say, let's say this is 1 right there, 1, then that sets my scaling both vertically and horizontally. So 1, 2, 3, 4, 5, 6. Why am I going out so far?
Because you're going to match the line.
Right? How far should I probably go? What's the period of this thing?
2 pi.
2 pi, right? 2 pi. So I want to make sure I get out there far enough to get out to where 2 pi sits. Right? And pi is sitting just past 3 right here. And pi over 2 is 1.57. We've learned that earlier in the course. Right? And I need to go negative on it also. Minus 1, 2, 3, 4, 5, 6, 7. One, two, three. Okay, so I roughly laid out my x-axis there, including my values of pi over 2, pi, 2 pi, so forth. Okay? Should feel okay to people. Now, I need to carefully draw a sine graph. Now, I know that the sine graph can't go any higher than 1, and it's going to peak out when it gets to pi over 2. And it's going to come back to 0 here at pi, and it's going to go down to minus 1 there. Oops, at about 3 pi over 2, which is right about here. And then it's going to come back to 0 there. So I'm going to carefully draw, I'll just dot it real finely on there as well. And similarly off to the left. I need to get as low as -1, back to 0, up to a crest of 1, and back to 0. Okay. Again, this is the artistic side of this trigonometry. So now what we're going to be doing is taking, as we move across here, as we move across through the domain, which is all real numbers, right? No problem with the domain here. And we're going to be taking whatever heights you see on this x graph, and we're going to add to them those sine readings. So you should be comfortable in realizing that between 0 and pi, you're going to be adding something to the values you see on this line here. You're going to be adding something to the values you see on the line. Something positive. So when I get to pi over 2, this linear function is how high? When I'm at pi over 2, how high is this? How high is this point?
Just under 2.
It's at pi over 2, exactly, isn't it? Isn't this y equals x? So this is exactly pi over 2 tall right there on the line. And then what am I adding to it? I'm adding 1 to it, aren't I? At pi over 2. This is the function, f of x. And so at pi over 2, I've got pi over 2 right here, plus the sine of pi over 2, which we know is 1. So to pi over 2 on the graph, that height between my fingers, I'm going to be adding this value of 1. But that's a little bit much. How about right there? Comfortable? How about here at the origin? If I add 0 to the sine of 0, I get what? I still get 0, don't I? 0 plus 0, adding those heights together, 0. What about when I'm at pi? I'm at pi, right? If I'm at pi, I'm on this line, I'm at pi. Right there. So at pi, my height is pi, because we know that the sine of pi is 0. And you can see it on the graph there, you're not adding anything to it. So, between these 2 points, I'm adding to these values on this line, I'm adding something, the most of which I'm adding right here at this crest on the sine wave. So I'm adding a little bit to the line, and a little more, and a little more, and a little more, until I'm adding 1 right here, and then I'm adding less, and less, and less, and less, and less, until I get to here, and I'm not adding anything. So my graph is looking like this. Superposition. We are adding one function to another function. What happens when you go past pi in the domain now? And you're heading towards 2 pi here. You're taking a little bit off, aren't you? See, these values are negative. You're taking a little bit of that stuff off of this height that you see on this linear function here. And so what's going to happen is you're going to get a graph that's going to be doing that. It's still an oscillator, isn't it? But it's it's oscillating, but it continues to rise. Continues to rise. Maintains itself as an increasing function. That's how you do it. Now your graphing calculator can do this in a split second without you having to even think about it, but you don't really learn anything from that. What about off to the left, folks? Off to the left, over here. You're down on these negative values on the line, and in this lower trough, you're going to be taking a little more away from the stuff on the line, aren't you? Until you get to pi, and you're going to be right back on the line, and when you get to 2 pi, you'll be back on the line. So we're going to be down below it here, and then here, in this region between pi and minus 2 pi, we're going to be above it. And it continues to oscillate in that fashion. We could make these any functions, couldn't we? Added together. Matter of fact, that's a whole branch of mathematics, is the superposition of trig functions. And you actually can build almost any waveform by adding trig functions together, sine or cosine functions together that happen to have different periods, that it might happen to have different periods. And there's a whole, like I said, a whole branch of mathematics that you can just focus on doing that. Let's jump to using our calculator for a moment or two. And you can just take some quick notes on this. You don't need to punch. All you have to do is just take some notes. So if we go to y equals, and let's say I took that original one, which was x plus sine x. Now I have to make sure I'm in radian mode here, because I'm mixing an algebraic function with a trig function. And so I have to be treating x as real numbers. So I have to be using radian measure here. So make sure you're in the right mode. Then you need to set a viewing window. And why don't I say minus 3 pi to 3 pi and put tick marks every pi over 2 on x. And then vertically, if I'm adding x to sine x, I know that my values, my y values, are going to be exceeding these, aren't they? By possibly 1, right? So why don't I go say minus 11 to 11 and put tick marks about every 3. And let me make it negative 12 to 12 every 3. So here we come. Here comes the graph. There it is. And if I now lay on separately the graph of just x, there it is right through there. Okay? So it does exactly what we predicted. And you can observe that at pi over 2, here's pi over 2, when you're at pi, they're right together. 3 pi over 2, 4 pi over 2, back together again. And notice also that we've added an odd function to an odd function. We added 2 odd functions together, and what was the result? Doesn't that look like it has origin symmetry, the thing we built? Yeah. So an odd function added to an odd function remains odd. Now watch this. Let me change this to be x squared. Now I'm adding a parabola's value. I'm adding sine x to a parabola's value. Now that window may not be very good, because look at this window. If I start squaring values near these are going to be enormous, aren't they? Right? When you square that, 81, bigger than 81. So I better build a range of values higher than that if I'm going to get out near there. Now actually the problem is I think I better not go so far. And I think I said minus 3 pi, didn't I? Yeah. Yeah, so let me just go to minus pi. And let's go to 2 pi on the right. And stick with pi over 2 there. And so now when I square this, it's going to be like 9. When I square that, it's like 36. So down here on my window, I think what I better be doing is go to, say, minus 10 and make this maybe 40 and put tick marks every 10. Now, I'm not even sure if we're going to see much here, but what are you going to expect? We have x squared plus sine x. Think about it. What are you going to expect? Huh? Okay, I'm not so concerned about the even odd character, but what are you going to expect shape-wise? Pretty much a parabola with a little wiggle going on the parabola. Let me get rid of that x thing. Looks like a parabola, doesn't it? Is it just x squared? Is it just x squared? No, what we're doing is you're adding up to 1 and subtracting up to 1 from the value of on the parabola, right? So what you've got is a little oscillator. It's like a little squiggliness going on that parabola. A little bit of squiggliness going on in the parabola, and we can't see it in this viewing window. I guess I could modify that window. How about maybe negative pi divided by 2? How about pi divided by 2? And just put tick marks every pi divided by 2 and see what we get here. Now I'm going to come down here and make this minus 4 to 4, 1, see what I get. Still doesn't look too hot. Check that out. This thing actually dips negative a little bit in there. And that's because of the oscillation going on because of the sine. Okay. Now, watch this. Let's take a sine graph and add to it a cosine graph with the same period, right? Each of them have periods of 2 pi. And let me set a window minus 2 pi to 2 pi, and tick marks every pi over 2. Here's a sine plus a cosine. Y equals sine x plus cosine x, and it looks like a perfectly good sinusoid, doesn't it? Except it's got a phase shift in it. It's got a phase shift in it. So if you ever take a function that is of the form a sine omega x plus b cosine omega x, same period, right? In this case, 2 pi over omega on both the sine and the cosine function. What you're going to end up with is a function whose amplitude is the square root of the sum of the squares of the amplitudes of the individual waves times a sinusoid. It could be either sine or cosine with a phase angle in there. And the period of this thing is, let's say I took a value here at, where do I see a nice value? The period's still going to be 2 pi. If I turn trace on here and go to negative 2 pi, no, it won't let me do that in the, what window did I have? Okay, it won't let me be exactly on there. How about minus 2.27? I'm sorry, I meant minus 6 point. Okay, and then if I check this y-intercept out right here, do you see how the value here effectively is 1? So the period remains unchanged. But there's a phase shift involved in that phi over omega. There's a phase shift involved in that model. And I don't have time to go into what that is, but all I want you to be aware of, folks, is if you ever see a sine wave, this is actually a pretty practical item that's not emphasized in our book, but if you ever see a sine wave and a cosine wave, maybe different amplitudes, but they have the same periods, then they turn into a single sinusoid with a non-zero phase angle giving you a phase shift on it. But the period will remain the same. Okay, we'll touch on this a little bit more in the next session, but I just wanted to point out to you there's some very interesting things when you start combining waves together. Okay, that's it for today. We'll see you Thursday. Don't forget the homework quiz. It'll be due Thursday night from last week's material.